All right, so in 1-5, we're solving equations or formulas. In science class, you would do things like this where you would have maybe, I don't know, E equals mc squared. There's a good science equation for you. And they'll say get m, the mass, by itself. So you'd have to figure out how to solve for that variable. We're just going to go through and look at solving equations for y equals, because eventually we're going to go through and we're going to graph equations of lines and then maybe parabolas later on. And if you look at your graphing calculator has this little button up in the top left corner that's y equals. So any equation that you want the calculator to graph has to have y by itself. So that's why we're going to practice solving those. So a lot of these examples we're just going to cross out, and we're going to add these other ones up here that I have. So as you go through and you fill in your notes, just cross the stuff out and you can fill this in. So if you look at this first example here, this first one here, we're going to solve this equation for y. So that means you want to get the y by itself, you want everything else on the other side. These are all going to end up being new equations. You're not going to get a numerical answer for these. So they'll just be a new equation that's sort of in a different order. A lot of these you'll end up with fractions for. So don't worry about if you get a fraction. It's not a big deal there. So your answer may not look easier or nicer than this original one, but it's in the form that we want it in. Okay. All right, so we want to get this. I'm just going to rewrite it here, and you can do the same. I want 3y by itself. So I want to get rid of that plus 4x. So how do you get rid of plus 4x? It's the opposite of plus 4x. Nobody's going to say anything. Minus 4x. There you go. So the 4x's cancel on the left side. We're left with 3y. And you have 9 minus 4x. Now, they're not like terms. You can't combine them together. They stay separate. So I'm going to suggest, while we're doing this, because we're trying to set these up for the equations of the lines that come in the next couple chapters, I'm going to say put the x term first. So you could write this as 9 minus 4x, or you could put it the other way around and make it negative 4x, and then this is positive 9. So I'm going to put the 9 second, and I'll put the x term first. Right, now on your test, if you made it 9 minus 4x, it's fine. It's equal to it. It's just in the next chapter, then when we start writing the equations for lines, you'll have to switch them around. So I'm just trying to get you to think of it in terms of that now. All right, you're almost there. We need this y by itself, so I need to get rid of what? The y by itself, so you need to get rid of the 3. Yep, so get rid of this times 3 by, divide by 3. Now when you divide this other side by 3, you're actually dividing each term by 3. So you can put a 3 underneath each of the terms there. The 3's cancel out. Negative 4 divided by 3. It doesn't simplify. Just leave it as the fraction there. 9 divided by 3 does simplify, though, and that gives me what? 3. Leave your answers with fractions. If you have, don't convert them to decimals. Leave them as fractions. If you can reduce the fraction, reduce the fraction. Because eventually, like I said, when we go through and we start looking at this plus 3 is going to be the y-intercept, where you're going to start on your y-axis to graph a line. This negative 4/3 is going to tell you about how steep the line is going to be. So that's why I'm trying to get you to put it in this form. This way it'll be all set for that next chapter. All right, this other example that I wrote over here, solve for x, you can cross that out. I'm going to end up sliding this up here so you guys can see these two down here. These, we will solve both of these equations for y. All right, and then I'm going to add a bunch in. Is anybody still copying this? Are you guys okay? All right. All right, so let's solve this first one here. So we want y by itself, so 3y minus x equals 7. What are you going to have to get rid of first to get 3y by itself? The x. Minus x, the opposite of minus x is plus x. So minus x plus x cancels out. You're left with 3y. 7 plus x can't be combined together. So we could write it as 7 plus x. Or remember, addition is commutative. You could write it in either order. We're going to put the x term first. We're going to do x, and it's positive 7, so it's a plus 7. Okay, and then what? Divide everything by 3. 3's cancel, we have y equals, just leave it as x over 3 and leave it as 7/3. Great, let's try letter B then. Letter B, you want the 4y by itself. Now it's on the right-hand side, that's fine. Get rid of the 5x by doing what? Minus 5x, because it's positive. So 5x minus 5x cancels out. You have just 4y on the right-hand side. 20 minus 5x can't be combined together. It can't be simplified. It stays that way. So you'll either have 20 minus 5x, or like I said, put the x term first. So it's a minus 5x, and what kind of 20 would it be? Yep, you're just kidding. It's plus 20. You got it. Positive 20. You got it. Okay, one last step. What is it? Divide everything by 4. Got it. So usually they'll put the y on the left-hand side. They'll just flip-flop this around. So negative 5 divided by 4 doesn't simplify, so we'll leave it that way. And then 20 divided by 4 is 5. Right, now on your test, if you left it in that same order, if you left it as negative 5x over 4 plus 5 equals y, that's fine. It's equivalent to it. When you do the math IXL for this section, I don't remember. I'll try it to see if it marks it wrong if you do it, if you write your answer this way as opposed to this way. I'll check it before we do that one. You guys kind of with me? All right? Okay, good. All right. So, so we're not doing any of these examples here, so you can cross these off. Right? And you can just use this space here then to write these other examples here. So we'll do one more together. No, you know what? I think you're going to do this one. So you guys do this one. This is the 2x plus 3y equals 6. It's on the board there, but I'm going to write it on here so it'll go in the video. All right, so you're going to get the y by itself. So work together. You can talk to each other. Get that y by itself. So y equals. It's not wrong, you're just adding more steps. You don't forget, if they're not like terms, most of the time you won't have like terms. So it's just going to stay the number of terms you start with. So here's the thing. First thing. Mark, what do you need to get rid of first? The x. And it's got a 2x. Subtract 2x. So you
Right, but we're solving for y. We need to get y by itself.
And the x are not always.
Always
And the x,
solving for y. Always getting y by itself.
You want this y by itself. Okay, I don't care about the x.
So yes,
This d, 6 minus 2x. You can combine it together.
But did I
we
do,
just learned.
did I do it correctly? If I was solving for the nine?
Yeah. Just 3. You want the y left there. You want y equals. You have to divide that one by 3 too. So you divide it.
Here's the-
Yep, there equals 1. Perfect.
Alright, so we want 3y by itself. Leave the 3y right where it is. Don't move it around. You can, but it just adds more steps into the problem. Get rid of this 2x. It's positive 2x, so subtract 2x from both sides. 2x's cancel, 3y equals. Now, don't forget, these are not like terms. 6 and a 2x, you can't combine together. They stay separate. Most of you are writing them this way, 6 minus 2x. That's fine. Like I said, in the next section, they would make it negative 2x and plus 6. They would put the x term first and then the 6. We'll do that with the final answer. And then finally get y by itself by dividing each term by 3. So the 3's would cancel on the left side. You get y. 6 divided by 3 is 2 minus 2/3 x. And you could leave the x in the top or you can put it next to the fraction there is fine. Either one's good. Or the better way to write this would be y equals negative 2/3 x, this term first, and the 2 is a positive 2, so plus 2. Right, so that's in the form that we're going to use in that next chapter there. All right, if you don't have room on this side, you can go right onto the next page there. If you're crossing out those examples, we're not doing any of those examples. All right, so you can go right on here. Oh,